Every drop of honey begins outside the hive. Worker bees collect nectar from blooming flowers and carry this natural source of sugar back to the colony. When they return, the nectar is passed between bees. Enzymes begin changing the sugars while water is gradually removed. Inside the hive, bees continue fanning their wings to concentrate the honey. Once it is mature enough, they seal the filled cells with a thin layer of wax. Only well-capped honeycombs are carefully harvested and sent for processing. You might think the hardest part begins when the honey starts to flow, but control actually starts much earlier. Honeycombs are received in large batches, inspected, and arranged into a fixed production flow. When the raw material enters the line, correctly from the start, the entire process downstream can move quickly while remaining clean and stable. Before the wax caps are removed, the honeycombs pass through a gentle conditioning stage. The goal is not to heat the honey, but to make the outer wax easier to process and bring the frames into a more consistent condition. A small preparation step can make the next stage much cleaner. Only enough of the wax cap needs to be removed to expose the honey-filled cells. Cutting too deeply can damage the comb structure. The separated wax is sent to its own byproduct route, while the opened honeycombs continue directly toward the centrifugal extraction area. This is where the honey is finally separated from the comb. The frames are balanced inside the extractor. The lid is sealed, and the speed rises gradually. Centrifugal force pulls honey from the cells without crushing the comb. The goal is not simply to spin as fast as possible, but to use enough force, maintain balance, and avoid unnecessary vibration. After extraction, the honey almost disappears from view. It is collected in a closed chamber, pumped through sanitary pipes, and sent through several filtration stages. Coarse filtration removes larger wax fragments, while finer stages handle smaller particles. The honey should still retain its natural amber color and thick consistency rather than becoming a crystal clear liquid like water. After filtration, tiny air bubbles still trapped in the honey need time to rise and escape. Instead of aggressive mixing, the system allows the honey to settle inside a tank. With a liquid as viscous as honey, sometimes leaving it undisturbed at the right moment is more effective than adding more mechanical action. One especially important parameter at this stage is moisture content. The honey enters a vacuum system where water can be adjusted under reduced pressure, while the process condition is monitored directly in the closed line. The entire operation remains enclosed without exposing the honey to uncontrolled open flow. Once the moisture level is under control, the honey is cooled, equalized, and transferred into the final stabilization tank. This is an important transition before packaging. The batch needs to become uniform, so the jars downstream maintain consistent color, viscosity, and fill level before a single drop of honey enters a jar. The jars themselves must be prepared. They are aligned, cleaned, evenly spaced, and moved into the exact position beneath the filling system. The lids and honey supply are also ready, because even one jar that is off-center can disrupt an otherwise clean filling cycle. This is one of the stages where the difference between simply moving fast and operating precisely becomes obvious. The filling nozzle lowers into the correct position. Honey enters directly into the jar, and each jar receives only one measured dose. Once the target level is reached, the flow is cut cleanly by an anti-drip mechanism so the rim, threads, and conveyor remain spotless. Filled jars are checked for fill level before receiving their lids. The lids are oriented correctly, placed straight, and tightened in a separate cycle. A vision system then checks lid alignment and the exterior condition of the jar. At industrial scale, even a very small deviation needs to be detected before the product continues. Once the jar is sealed, the label is applied. It must sit in the correct position, remain smooth, and keep the same orientation across every finished unit. A small batch code helps manage each production lot, after which the completed jars are organized into neat rows for packing. From this point on, the goal is to protect the glass jar during transport. Robots group the jars. Cartons are formed. Into the correct shape, the products are placed inside, and the cartons are closed. Each step happens once and in one direction, so finished products never return to an earlier stage. The smaller packs are then grouped into larger shipping cartons. These cartons are erected, loaded, sealed, and given an external lot identifier. Even as the quantity increases rapidly, the shape and orientation of every carton must remain stable in preparation for palletizing. In the palletizing area, cartons are stacked layer by layer in a fixed pattern. Slip sheets help stabilize the load. Then, the completed pallet is wrapped from the bottom upward. A pallet may look simple, but even a small layer misalignment can affect stability. During transportation, once a pallet is stretch wrapped, it does not return to the production line. Automated guided vehicles move it into storage, and finished lots are later transferred to dispatch and loaded for shipment. This is where the factory's one-way flow becomes clearest. Raw material enters from one end, while finished product leaves from the other. And finally, the finished honey jars are ready. Their amber color, viscosity, and fill level remain consistent with the moment they left the filling machine. But now they have been sealed, labeled, and protected through the entire packaging chain. A jar of honey may look simple, but behind it are dozens of transfers that must happen correctly, cleanly, and continuously.